Hello. Now that you know about elliptical orbits and how to calculate satellite velocities at their apogee and perigee, we can discuss Hohmann transfer orbits. These are elliptical orbits used to efficiently get from an orbit of one altitude to an orbit with a different altitude. Let's assume that you are in a spacecraft in low Earth orbit and you want to be in geosynchronous orbit. How do you get there with minimum fuel used? The answer is to use a Hohmann transfer orbit like I show in the image on my right. The small green circle represents the low Earth orbit. The larger red circle represents the geosynchronous orbit. The white ellipse represents the Hohmann transfer orbit, and the white arrows indicate the direction of the required rocket burns. This orbit was invented by a German scientist in the year 1925, before spaceflight was even possible with technology of the day. To accomplish this maneuver, you must fire thrusters to increase spacecraft speed in the direction indicated by arrows at point A. Use enough thrust to put the spacecraft into an elliptical orbit that intersects the final orbit at apogee. After you arrive at point B, you must fire thrusters again to increase speed, enough to get the spacecraft into the final circular orbit. You can use standard equations for circular orbit velocities and velocities at elliptical orbit apogee and perigee to find the change in velocity required for each burn. The change in spacecraft velocity required to enter the Hohmann orbit at perigee is equal to the velocity of the spacecraft in elliptical orbit at perigee, Vp, minus the velocity of the spacecraft in the low circular orbit, Vca. I show this in the image on my right. The change in velocity required to exit the elliptical Hohmann transfer orbit at apogee and enter the geosynchronous circular orbit is equal to the velocity for a spacecraft in the large circular orbit, VCB, minus the velocity for the spacecraft in the elliptical orbit at apogee, VA. I show this in the new image on my right. For this orbital transfer, you're required to increase speed twice, but the final velocity in the larger orbit is lower than the initial velocity in the lower orbit. If you find this strange, recall that spacecraft speed in an elliptical orbit is not constant. You must first increase speed to get into the elliptical transfer orbit at its perigee. By the time your spacecraft reaches apogee of that elliptical transfer orbit, the spacecraft's linear speed has slowed dramatically. Then, you must increase speed again to enter the larger circular orbit. Since larger orbits have slower speeds, your final linear velocity will be lower than it was in the smaller orbit. You can also use a Hohmann transfer orbit to get from a high-altitude orbit to a low-altitude orbit. To do this, the rocket burns must be opposite the direction of motion to slow the spacecraft in each case. We hope you found this video useful. If so, please give it a like and consider subscribing to the channel. If you want to be notified when new content is added, click on the notification bell. We plan to produce more videos in the future. We also need your feedback, so please leave comments. Goodbye.